Hi, today's lesson is about gravitation, and we're going to look at the nature of gravitational fields and what effect this has on mass. Now, there are four fundamental forces in nature, and they are gravitational force, electrostatic force, that's the force between charged particles, positive and negative. And then there are two more, which you may not have heard of before. That's a strong nuclear force. That's what holds the nucleus together. And then there's another one called the weak force. Now let's look at gravitational force and gravitational field. Now, anything that has mass will exert a gravitational force on the objects around it. This is because any object that has mass has what we call a gravitational field around it. So what is this gravitational field? It is an area around any object where another object will feel a force. And this gravitational field exists around all objects. And the shape of this field is radial. Whenever we talk about fields and force fields, we represent these by field lines. And the closer the field lines are, the stronger the field. And the arrow tells us the direction of this magnetic field, of this gravitational field. So the way that we represent a gravitational field is like this. Okay, so that's your radial shape, and the gravitational field of the Earth points towards the center of the Earth because the Earth draws everything towards its center. Now, Newton was the one who came up with this. And according to Newton's law of universal gravitation, all objects in this universe exerts a force on all other objects. And the size of this force is directly proportional to the product of their masses and inversely proportional to the square of the distance between them. That means the further apart two things are, the weaker the force. And also, the more massive the objects are, the greater the force. And so this is how we represent it mathematically, to show that Fg, or gravitational force, is proportional to the size of the masses. So there's a capital M and a little m. Sometimes this may be represented as m1 and m2, and r is the distance between their center of masses. R could also be represented as d in some cases. Anyway, it's a distance though. Now, whenever there's a proportionality sign, we can replace this by an equal to sign provided we have a constant of proportionality. So in this case, the constant of proportionality is capital G, and it's called the universal gravitational constant, and the value of this capital G is 6.67 times 10 to the power of negative 11 newtons per meter squared per kilogram squared. Okay, now the thing about this gravitational force is that it is always an attractive force, and it can also act over long distances. This explained why planets go around the sun. It explains why the moon orbits the Earth. They're all held in their orbits by this gravitational force. So that is the meaning of, that is what I have for today's lesson. And what you need to do now is work through the questions in your pink booklet under gravitational field. So bye for now.